Section 11.3, we're looking for magnitude and direction of vectors. Now, oddly, this is a section that causes some problem. There isn't any difficult idea here. I think the reason that this causes problems is because there's a nasty exam paper question that asks you to do all sorts of stuff with vectors, and at the end of it, it sort of says, well, find the magnitude of this vector, and people have just forgotten that finding magnitude isn't very difficult. So it's often the point on an exam paper question where people get things wrong, but there we go. So let's imagine we've got a vector here, vector A. Magnitude means the size. So what's the length of this vector? Well, let's imagine that this is P and this is Q, and that's the horizontal and vertical components. So this vector A can be written as PQ. Well, by definition, these two are at 90 degrees to each other, and this is the hypotenuse of a right angle triangle. Okay, so the magnitude has this notation. Oops. Vector A with little lines around it. It's the same as the modulus notation if you've met that before on mod A. So magnitude of A equals square root of P squared plus Q squared. It's that straightforward, it's Pythagoras theorem. Now, if I've got a vector, let's say vector A has a magnitude of 5. If I do 1/5 of vector A, what I get is a vector that goes, if vector A has a magnitude of 5, so I say magnitude of vector A equals 5. If I do 1/5 of vector A, I'm going to make a vector in the same direction as A, but a magnitude of 1/5, right? It's 5 times smaller, it's a fifth the size. So in other words, I get a vector of size 1 in the direction of vector A, okay? So vector A divided by 5 would have a magnitude of 1, okay? If I've got a vector and it doesn't have a magnitude of 5, it has a magnitude of mod A, then I take the vector and I divide by mod A. So in other words, I times by 1 over mod A, whatever mod A happens to be. Remember, mod A, like this, is not a vector anymore, it's a scalar, it's the size of vector A. So the magnitude, vector A times 1 over the magnitude of vector A, that's going to give me a vector in the same direction with a length of 1. Okay? Now, a vector with a length of 1 is called a unit vector. So a unit vector in the same direction as vector A, we can always get it by doing 1 over the magnitude of A times vector A. Now again, I think that's a fairly straightforward idea. If the magnitude of A is 7, then take the vector A, make it 7 times smaller, but in the same direction. So in other words, times it by a 7th. If its magnitude of vector A is 17, then times it by 1/17. It's that straightforward. And again, unit vectors, finding unit vectors seems to trip people up. The notation for that is often vector A with a little hat on it. So we say A hat, okay? So there's magnitude of vectors. Now, direction, there isn't a standard way of writing the direction. When we say direction, what we often mean is an angle, right? So if I've got a vector 4, 5, as I have in example 12, it says in this question, find the angle between the vector and the positive x-axis. Well, the positive x-axis is the horizontal line that goes that way. 4, 5 maybe goes something like that. So it's this angle here that they want, okay? So that goes 4 across and 5 up. So that's 4, 5, and we can do this now by trigonometry again. We're just using the fact that the horizontal and vertical components are at 90 degrees and the vector makes the hypotenuse of a right angle triangle. So the direction, there's no standard, it will be an angle. Sometimes it'll be an angle to the horizontal, sometimes it'll be an angle to the vertical. Often they'll ask you for bearings, so you'll be looking at a bird's eye view. North will be sort of the positive y-axis, and they're asking you for bearing of the vector, so it'll be that angle there that you're looking for. Just a quick reminder, bearing is you face north and turn clockwise. Whatever angle they ask you for, that's the angle you've got to find, and that's the only way that we can find the direction for the moment is just at a certain angle to the horizontal or at a certain angle to the vertical. One other thing I should mention is that there is a convention. So if I have vector A and vector B, well, it doesn't matter where vector A starts and where vector B starts, so I could draw them crossing anywhere. Now, if you look at that, the angle between vector A and vector B, you might think would be this angle here, but what about this angle here? There are two angles between vector A and vector B. Why should it be that we define it as this angle and not this angle? And the answer is that we're going to follow the convention, this convention in this textbook, which is like this. If I say the angle between vector A and vector B, then take the two vectors, oh sorry, I'll try and draw the same two vectors. Take the two vectors, so that one's A and B looks something like this. Draw them starting in the same place. So if they're starting in the same place, then it's clear which angle you're on about. So when it says the positive x-axis, well, the positive x-axis goes in that direction, in the direction of vector I, okay? So when in the last question, it asked me for the angle between the positive x-axis and the vector 4, 5, I drew it like this. I didn't draw it like this, okay? I didn't draw a horizontal line with the vector 4, 5 going through it, because if I'd done that, there'd have been two possible answers, that one and that one. I drew vector 4, 5 starting in the same direction as a vector that goes in, starting at the same point as a vector which goes in the direction of the positive x-axis, and that meant there's only one angle that I can possibly be being asked to find. A little bit of an odd one that, but that does make a difference in quite a few of the questions. So section 11.3 is done.